Okay, so now this is problem 49 on the Chapter 8, Chapter 9 review. It's asked us to graph using the vertex and 4 convenient points. Now, remember the vertex form is a times x minus h squared plus k. And see how this is almost perfectly of that form. The a is -2, and then the vertex, so this is what this vertex form, right, is equal to this. You could say y equals or f of x equals, and then the vertex is given by h comma k. So the difference is that this is a plus. So I can rewrite this -2, that's fine, and I can write this as x minus -3 quantity squared plus 3. And now it's perfect, right? A is -2, the x, the minus, right? And then h is -3. So the vertex is -3, and the k is the k coordinate of the vertex is +3. So now we know our vertex, right? I circled lines to it just so that you can see lining it up. H goes, that's h is -3. Okay, so now I want to pick 4 convenient points. And so, and I hate having it written like that. It drives me crazy. One thing that I usually say is that to find the vertex, it's my shortcut, if you will, is that beneath the square, you need the value that would make that 0. And that would be -3. Then put in -3 here and tell me what you get for y. So if this is 0, you square it, this whole thing is 0, and you get for y 3. And so that's my shortcut, is to find it by what would make this base be equal to 0. The base is x plus 3. That's if x was -3. So that's my shortcut for it. But you can certainly do the matches with the thing there. Okay, so this here, this is my vertex. They asked me for that. So my x and my y, or f of x, whichever one you want. Here's my vertex, And what you want to do is you want, it said 4 plus 4 convenient points. You want to pick values for x that are just really close to the vertex on each side of the vertex. So if I add 1 to the vertex, this would be -2. And if I took away 1, it would be -4. So I'm going to pick those 2 points there. Now when I put those in, I'm going to do the arithmetic here, and I got a calculator. And so I'm going to have here -2, parenthesis, and then I picked x to be -2, plus 3, quantity squared, and plus 3. And when I do the arithmetic, I get 1. Now, I expected, because this was the vertex, and I added 1 and I took away 1 to get those points, that when I put in -4 instead, so when I put in -4, I get also 1, and I expected to get 1. I just want to show you, just so that make sure that, oh, shoot, I didn't mean to clear that. That was a bad deal. When you put in -3, I just wanted to show you, when you put in -3, that you do get +3, like we said we were going to. Now I'm going to go back to the vertex. These were adding 1, right, to the vertex. Now I'm going to add 2. So if I add 2 here, I get -1. And if I take away 2, I get -5. And so I like to get points that are close to the vertex, and I kind of have my 1 away from the vertex and 2 away from the vertex idea. And these ought to be symmetric as well. So I'm going to have here, when I put in -1 there, I get -5. Now I'm thinking I'll get -5 for this as well. So I'll just go make sure, because that tells me that my thinking is right on everything, if I do, and I did. And then I'm going to plot all of these things. And so here's -1, -2, -3, -4, -5, right? And 1, 2, 3. I expect that my parabola, because this is negative, the a is negative, a equals -2, I expect that my parabola looks like this, facing downward, opening downward, right? Okay, so I'm going to plot these points, -3, 3, and then here's -2. That's 1 this side of the vertex, 1. And -4, 1, you notice the symmetry. And -1, -5, 1, 2, 3, 4, 5. And I would give you grid paper, of course, and -5, -5 to make it easier to have it line up. But there's my points on my parabola, and I know this is my vertex, so I'm just gonna, to the best of my ability, sketch it in there. Okay, let me make sure what they asked me to find. They said to find the vertex and 4 convenient points. So here's my vertex and here's my 4 convenient points. And graph it. So I've done everything they asked for, right? 50. So number 50 is not in vertex form. It's what's called standard form. Okay, so number 49 was in vertex form. So that meant the vertex was nearly for free and what it looked like. And this one here is in standard form. Now you have the choice. You can convert it into vertex form if you like, or you can use the shortcut. And I'm going to use the shortcut. So this is what vertex form looks like. F of x equals ax squared plus bx plus c. You can see that I have that. So that my a is 3 and my b is -6 and my c is 4. The shortcut for finding the vertex, so the x coordinate of the vertex is given by -b over 2a. Notice it doesn't use c, right? And this is just the first part of the quadratic formula, if you're remembering the quadratic formula. So this is negative of -6 over 2 times a, and a is 3. And so this is negative of a negative is a positive, so this is 6 over 6, which is 1. So the x-coordinate of the vertex is 1. And you're going to make your little table here, x, and you could call this y or f of x, whatever floats your boat. It does not matter. 1, and I'm going to put a v there for vertex. And then how you're going to find the y-coordinate of the vertex is just like you did in the other, is you just plug in what the x-coordinate is, right, into the equation. So the equation here is 3 times 1 squared minus 6 times 1 plus 4, and we get 1. So coincidentally 1, 1. And then I want to find the convenient points the same way I did. So I'm going to add 1 to this vertex. I'm going to take away 1, and these are symmetric. And I'm going to add 2, and I'm going to take away 2. And those are going to be my convenient points. So I'm going to go put in 2 into my calculator to find the y-coordinate that goes with that. And I get 4. When I put in 0, I should get 4 as well. And you could kind of see that if you put in 0 there, that you would get 4. So maybe I won't even spend the time putting it in. And I expected that those would be the same. And if they weren't the same, then that was going to let me know that there's something wrong with my thinking of how this parabola is going to go. I'm using my symmetry. So when I put that in, I get 13. And when I put in -1, I ought to also get -1. I ought to also get positive 13. So if I don't get positive 13 when I put in this -1, then I'll know there's a boo-boo. I did put in 0 here. I just put it in myself in my head. I didn't use my calculator, right? And so now I'm going to plot these things, and I'm kind of noticing this goes to a height of 13. And so I'm going to kind of draw it like this. So here's 1, 2, 3, and 0 and -1, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I don't have the best scale, but doing my best, right? And I don't have grid paper, but you can get grid paper. I just don't happen to have it on me. 1, 1, that's the vertex. And this parabola, because A is positive, I expect that it's going to be looking like this, opening upward. So 2, 4, and 0, 4. You can see that it's kind of a skinny parabola. And then 3, 13, and negative 1, 13. So this skinny little parabola. Okay, so I have the vertex, I have 4 convenient points, and I have plotted them. Okay, so that's good. And 51. Is actually both in standard form and in vertex form at the same time. If you want to think of it as being like that, you certainly can. So if you're a standard form kind of person, then what you're naming is your A. Your A is negative 1. Your B is the coefficient of x, which there isn't, so it's 0, and your C is 3. So your the x-coordinate of the vertex, x-coordinate of vertex, is given by negative b over 2a. So this is negative of 0 over 2 times negative 1. And 0 divided by 2, or negative 0 divided by negative 2, whatever you want. Whenever you have 0 in your numerator, this is 0. So the x-coordinate of the vertex is given by 0. And then the y-coordinate of the vertex, you can find it, you call it f at x if you want, just by plugging in, right? And you could use your calculator or you could use your head. So this one is negative of, and then 0 squared, and then plus 3. And so you could, hopefully you said 3, right? Now I'm going to add 1 and take away 1. I'm going to add 2 and take away 2 to get some convenient points. And when I put in 1, I get 2. And when I put in negative 1, I ought to get the same value, because those are my symmetry. And so I'm going to put in here 2. Actually, I have in here negative 2. I got negative 1. And then I'm going to put in here positive 2. So when we plot, so here's our vertex, right? So we plot this over 0 up 3. It's going to open downward, right? A is negative, so it's going to open downward. So just so I know what to expect. Over 1 up 2, over negative 1 up 2, over 2 and negative 2, and we're down 1. And so here's my lovely little parabola. Oh. Sorry, I missed hitting my dot. I'm trying to look at 2 different monitors, and that's what happens when you... So I have my vertex, my 4 convenient points, and my graph. Now, I did it using standard form. This is also vertex form, actually, because remember how vertex form looks? It looks like a times x minus h squared plus k. And so you can write this as negative 1, right? And then instead of, because this is x squared, you can write this as x minus 0 squared. See how that's the same as x squared plus 3. And see how h is 0, and k is 3. So it was actually in both forms. It was in standard form and vertex form at the same time. I think that I like standard form. Just me. You can like whatever you want. I don't require you to like what I like. There's a song about that, I think. Is it I Require You to Like What I Like song? I don't think so. Okay, so 2x squared plus 3x is greater than 0. And I want to solve and graph the solution. And so we're gonna do that. How you solve these is you find the boundary. And the boundary happens at equals. So you find 2x squared plus 3x equals 0. So that's the first step, is to find the boundary. So this is quadratic, and I wouldn't want to use the square root method to solve it because it has a middle term. Because it's a binomial, I think to myself, oh, I hope I can factor it, and I can. I can factor out an x. So this is 2x plus 3 equals 0. So I get my boundary points are x is 0, and 2x plus 3 equals 0, taking away 3, and dividing by 2, I get my boundary points are negative 3 over 2 and 0. Now, just because I'm going to plot these, that's negative 1.5, right? And so those are my called boundary points. What you do with your boundary points is you put them on your number line. So that's the second step. So here's 0, and negative 1.5 is over here. So negative 3/2 or negative 1.5, either way. And then this tells me that you're going to have open circles. So these are going to be open right here. So open circles. Closed means that the boundary is part of the solution. Open means that the boundary is not part of the solution. So the solutions are the things that are greater than, on this side, than 0. Not the things that are equal 0. And these things equal 0. And so that's why the open circles here. And then what you do is a test point. And you only have to test one region. So test any point that you want. Some people say test every region. I'm pretty lazy. So you do a test point. And I'm going to test x as 1. Just because I know where it is. It's in the region that's bigger than 0. And you're going to test it in your original equation. So 2 times 1 squared plus 3 times 1 is greater than 0. And this is 5. And that's greater than 0. That's true. So this means this is a true region, which means it is part of solution. And the good news is the quadratic ones, they alternate every other region, but you can test something in every other region as long as you have, so if you have degree 2 and you have 2 boundary points, then it'll alternate. So this will be false, but you could go test it if you wanted. So you could test something in here like x equals negative 1 if you liked. 2 times negative 1 squared plus 3 times negative 1 is greater than 0, right? And I probably in the video said test a point in every region because that's just the safe thing to do. And then that doesn't require that you know that it alternates only if the degree matches the number of boundary points, right? And so you don't have to know anything when someone says test something in every region. So I'm guessing this over here is going to be true. I'm going to test x is negative 2, and I'm going to go back to my original conservative test a point in every region story. So when I put this in, this is 2 times 4 is 8, minus 6. My computer is saying, plug me in or you'll be sorry, is what my computer is saying. And I have 2 is greater than 0, and that's true. Okay, so now that I've done that, I'm just ready to put my answer and write my answer out. Okay, so this is the last story here. So the graph of it, they put a line here to show this is where my solution is. For 0, this is the graph of my solution. So where my true is, I put my lines. So this is the graph of my solution. And they write their solution also in in set notation. Do they use set notation? Oh my gosh, I can't remember. I'm going to have to go get your book to make sure that I don't use interval notation when you don't know how yet. I don't want to use interval notation if they haven't taught you how, and I just don't remember if they teach me how later. I think they teach me how in chapter 10, but then that's my memory of the whole situation. So I'm just making sure that they're going to use set notation and not interval notation, and they're using set notation. So I don't want to rock the boat. So this says that x is smaller than 3 over 2, or x is larger than 0. And they write it, I think, in fancy set notation, but I'm okay with this. This is informal set notation. Actually, they write it in informal set notation as well, so I'm just matching them perfectly. Okay, so there's my answer. And 3 easy steps, right? Okay, so we'll try the next one. So that was 52, this is 53. So x over x minus 1 is less than 0. Now this is not quadratic inequality, this is rational inequality. That's a fraction. And so you have to find, to put on your number line, you have to find where it's undefined. And where it's undefined, undefined got an E in it instead of an I. How'd that happen? Undefined is where the denominator is 0. So that's where x minus 1 equals 0. That's where x equals 1. Now, undefined's not a good spot, and so this should always be open. And so when I put this on my number line, it's going to be open. Then the other thing I want to find is the boundary. And the boundary happens at equals. So you solve x over x minus 1 equals 0. So the first step to solving this solving this would be to clear the fraction. So I'm going to multiply both sides by x minus 1. So this will be x minus 1 times x over x minus 1 equals, and then x minus 1 times 0. So I'm just multiplying by the denominator there. So the x minus 1's cancel, and I get x equals, and then x minus 1 times 0 is 0. So, and this is either open or closed. Open if I have greater than, less than, and closed, this is always, the undefined is always open, and closed if I have greater than or less than or equal to, which is what I have on this problem. So these are going to be closed. So then the next step is to go to your number line, right? So you find where it's undefined, you find your boundary point, and you put these things on your number line. So I'm going to put 0 on my number line and 1 on my number line, and 0 should be closed, so I'll make it solid, and 1 should be open. And then what you do is you test a point in every region in this original equation. So I'm going to test x equals like -1, because that's in this region over here. I'm going to test x equals half, because that's in between, or 0.5. And I'm going to test x equals like 2, something in that region. And I'm putting it in the original. So the original looks like this: x over x minus 1 less than or equal to 0. And I'm going to be putting in the -1 right in there for x. And I want to see, is it true? So I'm going to do my calculator on this. So in the numerator, I want -1, because that's what my x is. And in the denominator, I want -1 take away 1. So this is half is less than 0. And that is false. So this is false. And then I'm going to test half. So everywhere in here, now half is the same as 0.5. So I'm going to just put in my calculator. So right here's where x was 0.5. So I'm just kind of editing here. And 0.5. So I get -1, because that's what when I put this in, right? -1 on this side is less than 0, and this is true. And then I'm going to put in 2, right in here, 2. So right where you see x, I'm going to put in 2. So I'm going to go change the half to 2. And this is giving me this side over here, right, which is 2. Coincidentally, it's 2. And that's false as well. So this is false. So now I'm going to answer the question. So my solutions are in between. This is where my solutions are. They're in the true region, and you just make a line over the top of it. So there's my graph of it. Then they also asked me to write my answer in set notation. And so my answer are x's that are trapped between, and they can be equal to 0 and smaller than 1, right? So my x's are between 0 and 1, and they can be equal to 0. So there's my graph of my answer, and there's my answer in set notation, informal set notation. So we did a lovely job on that. And now we're going to try 54. So I noticed that it's fraction inequality, right? And so there's two things you look at. You look at where it's undefined. In either order, it doesn't matter. And that's where the denominator or denominators, if there's more than one, equals 0. So x plus 2 equals 0. So that happens at x equals -2, and this is always open. Then you look at the boundary. And the boundary, it happens at equals. So just turn that into an equals. X minus 2 over x plus 2 equals 2. So I'm going to multiply by x plus 2 both sides to clear that fraction. X plus 2 times x plus 2 on this side as well. The x plus 2's cancel. And on this side give x minus 2. And on that side give 2x plus 4. And I'm going to solve that for x. So it's linear, so I'm going to take away 2x and add 2. So I get -x equals 6, or that x equals -6. And either way you want to do that. And this is opened or closed, depending on what this says. And this says closed. So this is closed. They could be both open if that had been strict inequality. Then the next thing is to test points in every region. So here's -6, here's -2, -2 was open, -6 was closed, and I'm going to test points x equals, and I'm thinking about testing -7, and then in between, like x equals -5, and then x equals, so -5 is in between. You could pick -3 if you wanted, or -4, and I'm going to pick 0 over here. So above -2. And then remember, you're plugging this back into this original equation, and you're asking yourself, is this smaller than 2 when I plug it in? So I'm going to get my calculator here and get my fraction going. And I want -7, so I'm going to put parentheses around it. -7, just so that it'll be easier for me when I edit. -2. Parentheses are implied when you substitute, right? -7, and then plus 2. And I got 9/5, and that's 1.8. So 1.8, is that smaller than 2? And the answer is true. That's true. True, true, true. Okay. So over here is true. And then I'm going to do -5. So I can just edit So where I put in 7, I'm going to put in -5. And I get 7/3, which is 2.2. It goes on, right? Line over the top of it. Smaller than 2. No, that's bigger than 2, so this is false. And I accidentally cleared what I had been putting in. I hate when I do that. So I can do this one by hand, because 0, so 0 lives -2 in the top and 2 in the bottom. So this is -1 is smaller than 2, and that's true. And now I'm ready to say my answer. So I scoot over here a little bit, 4 easy steps, right? So here's my answer. So -6, and you make your line where the true regions are. Okay, and then this is going to be an or. So x is smaller than or equal to -6, or x is larger than -2. And that will be my graph of my answer and my answer. And then we're on 55. And this one's quadratic. It doesn't have a place where it's undefined. Undefined happens where your denominator is 0. So all I have to do is worry about the boundary. And that happens at equals. So where 2x squared plus 4x equals 6, or where 2x squared plus 4x minus 6 equals 0. And I can factor that. I don't want to use the square root property because I have the middle term, but I can factor that, or I can use the quadratic formula. And I'm thinking about factoring out a 2. And I was hoping that it would factor, but they need to 1 and 3, and they need to subtract to be 2. Oh, they do subtract to be 2. I'm sorry. That's good. It factors. Yay! I'm glad I wrote it out and thought about it. So this is 2 times x minus 1 times x plus 3 is equal to 0. 2 never equals 0, so that's not going to give a solution. X minus 1 equals 0, where x is 1, and x plus 3 equals 0 when x is equal to -3. And so what you do with those is you put them on your number line, and the boundaries are either open or closed depending on this. And this is open, so these are both open. And the boundary points will all be the same, and so I put these on my number line. And then you test in this original inequality, and I want to test like -4, something in the before, something in the in between. I'm going to test 0 because that's easier on my arithmetic, and in something in over here above, like 2. And I'm comparing this to 6. I'm saying this is greater than 6. So I'm going to put this in my calculator. I'm just going to use my calculator. So it says 2, and then I chose -4. And plus 4, so here's 16. And 16 is greater than 6. This is true. I forgot to put my open circles on there, sorry. So I'm going to put them on there now. And then I'm going to put in 0, and I can do the arithmetic for 0 on my own. 0 is bigger than 6. Nope. Right, this was true. And then I'm going to put 2 in. And I can go and I can edit and put in 2. You can also do it with your head. And I get 16, coincidentally. And this is true as well. Oh, I was writing true and false and then making my judgment over here. And I forgot how I was on it. So here, and here, and this is here, and here's here, and then my answer is x is smaller than -3, or x is greater than 1. And there's my answer, there's my graph, There's the whole business. Okay, one last one to do. And I feel kind of happy because 56 is kind of similar to the one I just did. The difference is the symbol. Here, like this. So I'm not going to get anything different when I do the boundary because the boundary had nothing to do with the symbol, right? Do you guys agree? So the boundary, since these are the same, is the same. So I'm not even going to do it. So I would get here and have -3 and 1, right? And open and open. And when I go to test points, like -4, do you guys agree with me? Because this is going to be changed, it's the symbol changed, right? Is 6. I would still, when I put in, because it's the same function, I still get 16. But what I would get instead is false. Do you see how that's going to go? False. And this would be true, and this would be false, right? Everything's just the opposite, so that when I go to write my solution is here, open circle, and my solution is trapped between -3 and 1. So we did a lovely job on that. That was 56. And I'm watching the time because I have a 1 o'clock class and it's getting close to that. I think I can get them done. Oh, wouldn't that be a miracle? 57. Because it's just the word problems left. So you have a room and they have, it's 12 foot by 14 foot. And they're going to run wire under the carpet. So they got the carpet up right now. And they're going to put a wire that goes from one corner of the room to the other room corner, right? And they want to know how long does the wire need to be, right? And there's going to be 4 feet slack at each end. So 4 feet over here slack and 4 feet over here slack so that they can plug it in. And so this is just the length underneath the carpet. So do I have anything that would help me find just that length, right? Because I already know I need 8 feet, but how much more do I need going across there? Yeah, and this is a right triangle. And so even though I know it's a rectangular room, because of going on the diagonal, it makes it a right triangle. And then you can use the Pythagorean Theorem. So 12, right, this is my A and my B. Those are my legs. And here's my C, my hypotenuse. A squared plus B squared equals C squared. So 12 squared plus 14 squared equals C squared. So 12 squared plus 14 squared is 340 equals C squared. And then I could just take the square root of both sides. I have that property, right, that if I have a base squared equals a number, then this is the base equals plus or minus the square root of that number. You guys remember that, the square root property? And because it's length, right? So when I put this in my calculator, the square root of 340, my calculator gave me 2 square roots of 85. It simplified it for me. But I want to know what it is as a decimal. So that's 18.4 feet. And it's positive, right? Because it's length. It's not negative. And then I'm going to add 8 feet onto that for the slack. 8 feet slack. So this is just from here to here is 18.4. So I'm going to add 8 feet onto there for the slack and make my calculator tell me as a decimal. So 26.4. Now it said to round up to the nearest foot, right? This was already ... but it said up to the nearest foot. So it's going to be 27 feet. It said always go up. It didn't say round accurately right? It said up. And that's what's going to happen when you're buying something, because let's say that I really needed all of this, you know, I tried to put in some fudge factor here, but let's say that I needed all of that room and I just went to the Home Depot and got 26 foot of wire. Then I would be like, you know, 0.4, that's almost half a foot short. That's almost 6 inches short, you know, if I did that. And so I really need to round up 27 feet. And so that's why it said round up. So any partial, you would go up. Okay, 58. So there's times when you round appropriately, and there's times when you round up. And so I can't think of a time right now that you round down, but there probably is a time when you round down. Okay, the formula, this is 58, gives below the time in seconds. I think we did this one. The square root of 2x over g, and they told us that gravity is this and x is the distance that we're going to fall in meters. Yeah, and so in the problem I had before, that got kind of weird there. I had, like I'm remembering, like 7 feet that it fell, but now it's 174 feet, meters that it's going to fall, right? And then 9.8 here. And this is going to give us the time in seconds. And so time in seconds. So I'm going to put that in my calculator. Fraction. 2 times 174. 174 is a lot to fall. And did they say what it was? It was falling? I don't think they did. Okay, and then I want to get this, and so 5.95, and they said to the nearest tenth of a second, so you would, this is 5.95 to the 10th would mean here, but you need to round up, so this is t equals 6.0 seconds. Okay, that's how long it would take to fall 174 feet. That's a long time. 6 seconds. Okay, S equals the square root of 30 df. And it says use this formula, so there's my formula, to determine the approximate speed of a car before the brakes were applied. S is in miles per hour. It is the speed of the vehicle before the brakes were applied. D is the number of feet. It is the length of the skid mark. F is unitless, and it's a friction. It's the friction coefficient, the drag factor of the road. And it said find, and I've heard that in Kern County that's typically 0.6 because we don't typically have rain or snow or sleet, and so anyway, so I heard that Kern County cops use 0.6 for that typically. And so they'll use a different F depending on the road conditions, how much oil is on the road, how much water is on the road, etc. Okay, so it says find the speed in miles per hour of a car before the brakes were applied if the skid is 184. So they're telling us that D is how did I read 184? Just 84, sorry, feet. And then they asked us to use F to be 0.6. So we're just going to plug and chug, and this is going to give us our speed of the car in miles per hour. So 84 goes in here, and 0.6 goes in here. And as long as you have the units right, so this was supposed to be in feet, this will be in miles per hour. That 30 is adjusting the units and all of that, so it's a formula given. I got this formula from a police officer that came and visited my class and talked about how they determine how fast you were going before you hit your brakes. And so, of course, they don't tell the judge 6 times the square root of 42. They tell the judge that they were going, and it said round speed to the nearest mile per hour. So this is 38.8. So I want to chop this off and I want to go to the nearest, and so this is really 39 miles an hour. And so if you're in a 40 mile an hour zone, you're okay. But if you're in a school zone that's 25 miles an hour, that's not so good. That's my alarm telling me you got 5 minutes to get to class. So I think I can solve this problem in 5 minutes. So that'll be good, and then I'll be done. So it gives me a formula on 60. Use s to equal 16t to the second to find the distance s in feet of an object that will fall in t seconds, neglecting air resistance. In order to determine, so that's the formula, and they kind of told you a little bit about the formula. In order to estimate the depth of a vertical mine shaft, Kevin drops a rock down the shaft. Approximately how deep is the well if the rock takes 2.1 seconds to hit the bottom? So they're asking you to find out how deep the well is, and he's got this. I don't know how to draw a well, but here he is. Here's Kevin, and there's his head. Here's his arm, dropping a rock into the well. Yeah, he's laying down because his mom won't let him walk up to a well and stand above it and drop a rock. So he would have to lay down because I don't want him to fall into the well, because I really like him a lot. And so they want to know how deep the well is, and that's how far the rock fell. And this formula talks about telling you the distance that something fell. And they say that the time that it takes to hit the ground is 2.1 seconds. There's all kinds of mine shafts out in the desert. If you're not careful, you'll find one by falling in it. So hopefully you'll be careful. But where these mine shafts come from is they used to dig out there looking for, all kinds of things, silver and boron and all kinds of stuff. And anyway, so they have these, and we like to drop rocks in them. It's fun. But that's why I say you have to lay down when you're doing it. So this is because we're estimating how deep it is. So 16, and then times 2.1 seconds. We have everyone, using their phone to time it, and then taking the average, because that's how crazy we are. So S equals 70.56 feet deep. Remember they said that S would be in feet. And did it ask me to... It didn't say, it said approximately how deep is the well. It didn't tell me where to round. So it didn't say to round to the 10th. It didn't sound to round to the nearest foot. But probably I would be telling everyone, and it was 71 feet deep, is what I would probably be telling everyone, rounding to the nearest whole number, right? Because this is a 0, and that's 5, bump up to 71 feet. Okay, so that's that. Yay, we did it.